All right, so the recording has started, so let's dive into today's discussion. Okay. All right, let's move on. Okay, so as we were discussing, the title of this course. Remember, the title of the course is Design and Analysis of Algorithm, right? Okay, now, মনে আছে? একটু আগে discussion করছিলাম. Yes.
Yes, sir.
Yes, sir.
So the course is called Design and Analysis of Algorithms. Okay, that's our course title. Okay. Now, একটু আগে discuss করছিলাম, but can anyone tell me what does analyzing an algorithm mean? What is the purpose of analyzing an algorithm?
Sir, to choose the better solution out of the many successful solutions
Well,
available.
that could be one, okay? Or if we have just one algorithm, then I'm not choosing the better one because it's just only one algorithm. So then what would be the purpose? How about why do we analyze the algorithm? We analyze the algorithm to see how good the solution is, right, Nakina? Yes?
Yes, sir.
Right, sir.
Yes,
Yes, sir.
Okay. So now the question is, how do we do the analysis? What tool do we use to actually analyze the algorithm? It turns out that the tool that we're going to use to analyze algorithm is mathematics. So we're going to use the mathematical concepts, okay, all right, to actually analyze the algorithms. Is it clear, Nakina? Yeah.
Yes, sir.
ঠিক
Yes,
আছে।
sir.
Clear, sir.
এবং একটা ভেরি ইন্টারেস্টিং থিং হচ্ছে আমরা যখন ম্যাথমেটিক্স উই গোইং টু ইউজ ভেরিয়াস কনসেপ্ট অফ ম্যাথমেটিক্স, ঠিক আছে, various concepts of mathematics will be used. Okay, so what are the different concepts of mathematics that we use? So some of the concepts you will see probably is um, let's say series, ঠিক আছে, okay, series like for example AP series আসতে পারে, GP series আসতে পারে, ঠিক আছে, right, নাকি না, clear? Yeah. So all
Yes,
these
sir.
things are there. Then you will have concepts like, let's say, calculus আসতে পারে, ক্যালকুলাসে তোমার কি আছে, ডিফারেন্সিয়েশন আছে, ইন্টিগ্রেশন আছে, ঠিক আছে, রাইট নাকি না? Yes.
Yes,
Okay.
sir.
Okay.
Yes, sir.
So lot of different techniques, okay, different mathematical concepts that we may require. Is that okay, Nakina? So lots of various interesting mathematical concept would be used in analyzing an algorithm. ঠিক আছে? Okay, right? Is it clear so far?
Clear, sir.
Yes,
Okay.
sir.
Yes, sir.
Now, unfortunately, very unfortunately, now I'm sure you guys have done AP series, GP series in the school. তাই না, নাকি না?
Yes, sir, we did.
এই যে এগুলো করেছেন না, AP series, GP series? Yeah,
Yes, sir.
করেছেন?
Yes, sir.
I'm sure you guys have done these things in the school. But then again, আমি অনেক সময় দেখি যে যখন এই কোর্সটা পড়াতে যাই তখন দেখি যে আসলে এপি সিরিজ জিপি সিরিজের ব্যাপার স্যাপার আসতে স্টুডেন্টসরা সব মানে ভুলে টুলে বসে আছে, ঠিক আছে, they have forgotten a lot of things. So what all I'm going to do is I'm going to today discuss this AP series, GP series that you learned in the school. So the whole point of doing this one in today's class in lecture 1 is so that you do not forget this. Even if you have forgotten, you recall these concepts that you have done in the school, right? কারণ in future আমরা যখন analysis করব algorithms you'll see AP series, GP series এইসবের concept গুলা will come back. ঠিক আছে? Is it clear নাকি না? Are we good?
Yes, sir, good.
Yes, sir.
Yes, sir.
Is that
Yes,
okay? কিছু ক্যালকুলাস আসবে, বাট আই এম শিওর ক্যালকুলাসটা অত বেশি আসবে না আমাদের কোর্সের জন্য, সো ওইটা তখন দেখতে পারবো। এবং এছাড়া হয়তো বা there are other things like tree diagrams and stuff like that, but এগুলো নিয়ে let's not worry about it right now. So আমি at least এই সিরিজ সেকশনের ব্যাপারটা I want to resolve that one today. Okay, right. So let's get started. So I hope you understood what we're going to cover today, right, Nakin, and why we are covering it today. ঠিক আছে? Okay. Great. So let's get started and let's start looking into AP and GP series. So I'm going to start with AP series. Okay. So let's start with the AP series. Okay. So here we are. AP series. Okay. Now what does AP stand for?
Sir, arithmetic progression.
Arithmetic progression. ঠিক আছে? It's a series, right? You know?
Yes, sir.
Okay. Now let me give you some examples of AP series. ঠিক আছে? Let me give you some examples of AP series right here. So examples of AP series. So here's an example. 2, 5, 8, 11, and so on. Is it an AP series? Is this sequence of number belong to AP series? Does this, yeah?
Yes, sir.
Yes, sir.
Yes,
Common
sir.
difference is the
Well,
same.
why do you think this sequence of number belongs to AP series?
So difference is 3.
Common difference has the same value.
So difference is 3 throughout, right? Nakina, throughout the series. Difference means you mean that the difference between successive numbers, right, Nakina? Yeah? The
Yes, sir.
difference between successive numbers is constant throughout. 2 to 5, the difference is 3. 5 to 8, the difference is 3. 8 to 11, the difference is 3, right, Nakina? Yeah?
Yes, sir.
Yes, sir.
Okay.
That is noticed.
Right. So some more example. What about this one? Is it an AP series? 3, 4, 5, 6. Is it an AP series?
Yes, sir.
One common difference.
Yes,
Yes.
sir.
Yeah.
Yes,
So
sir.
that's an AP series as well. What about this one? 5, 3, 1, -1. What about this one?
Yes, sir.
Yes, sir.
Is it an AP series? That's an AP series
Yes,
as well.
sir.
Yes. Right. Okay. An AP series, okay, has two very important parameters. One is the first term, so it needs to start with a term. Like for example, in the first series that you see over here, the first term is 2. And the second series that we have, the first term is 3. And the third series that we have over here, the first term is 5. Is that okay, Nakina? So any AP series must have a first term. So it must start with the term, right, Nakina? It must have a first term and it must have a common difference. Okay. So mathematically, we denote the first term with A and the common difference with D. So what is A? What's the first term for this series? 2, 5, 8, 11. What's the first? 2. And what's the common difference here?
3.
3.
Common difference is 5 minus 2, which is 3. Or you could say 8 minus 5, or you could say 11 minus 8. মানে পরের টার্ম মাইনাস তার ঠিক আগের টার্মটা, রাইট নাকি না? Is that okay?
Yes, sir.
Yes. আচ্ছা, ঠিক আছে. What about this one? What about the second series? What's the first term here?
3.
3. And what's the common difference here?
1.
1. Very good. Okay. Acha, very good. What about the first term here?
5.
5. What's the common difference here?
Minus 2.
Minus 2, not plus 2. It's minus 2. 3 minus 5. Okay. Next term minus the previous term. 3 minus 5. Or 1 minus 3. Or -1 minus 1. Right? So that's minus 2. Is it clear, Nakina? Yes?
Yes,
So
Yes,
if a series has a first term and if a series has a common difference, a difference that is constant throughout the series, then this particular series belongs to the AP series. Is that okay, Nakina? Are we good?
Yes, sir. Good.
Yes, sir.
ঠিক আছে, কারো কোনো question আছে at this stage?
No, sir.
Acha. So you see, these are specific examples of AP series. But let's say mathematically, যখনই কোনো mathematics দেখি, we want to see a general pattern. How does the general pattern looks like? So the general pattern, so what is the general pattern of an AP series? So let's see. Okay, general pattern of an AP series. Of an AP series. Okay, so we have a first term which is A. If the first term is A, so we start with the term, that's the first term, right? That's called A, right, Nakina? Yeah?
Yes, sir.
So now you see, I don't give any specific value because we are looking at the general pattern. So we are trying to denote it using, you know, A, B, and things like that. Okay, so if the first term is A, can you tell me what's going to be the second term?
A plus D.
A plus C, exactly. So look at this. If the first term here is 2. How do you get the next term? So you added
A
a
plus
3,
D.
which is the common difference to that, right, Nakina, to get the next term. Am I correct?
Yes, sir.
Yeah. So similarly, if the first term is A, the second term would be A plus D. Right, Nakina? Yes, agreed?
Yes.
Okay. What will be the next term? So you add another D to that,
A
like
plus
5
3D.
plus 3 is
A
8.
plus 2D,
So
sir.
you add another D, so it would become A plus 2D. Am I correct, Nakina? Yes?
Yes, sir.
What would be the next term?
A plus 3D.
A plus 3D. And this is how the, this is how the sequence will change, right, Nakina? Yeah? Okay. This is how the sequence will grow. Is that right, Nakina? Are we good?
Yes, sir.
Okay. Now let's also look at the term number. Let's look at the term number. What do I mean by term number? Okay. So I said this is the first term. So it's a term 1. This is the first term, right, Nakina? First term is A. Second term is A plus D. The third term is A plus 2D. The fourth term is A plus 3D. Right, Nakina? Yes?
Yes, sir.
Yes, sir.
And this is how it keeps on going. So now the question is, what would be the nth term? What do you think? Can you see that?
plus N minus 1D. Plus
Yeah, so if you see the
ND.
fourth term is A plus 3D. 3 is 4 minus 1. If you see the third term is A plus 2D. 2 is 3 minus 1. If you see the second term is A plus D. 2 minus 1 is 1D. Okay. So you can see a generic pattern here, which is A plus N minus 1 times D. Am I correct, Nakina?
Yes, sir.
yes, sir.
এটা সবাই এগ্রি করছি আমরা নাকি না করছি না?
I agree.
Are we okay? Okay. তার মানে we have jumped to a conclusion. We have reached a conclusion here. And the conclusion is my nth term of an AP series. So I'll write it down here. My nth term of an AP series is A plus N minus 1 times D. Agreeable, Nakina?
Yes, sir.
Yes,
Agree.
sir.
Okay.
বৃষ্টি হয়?
This is agreeable, right? Sir, বৃষ্টি হতে পারে, sir, but look at here. Okay. So are we happy with this, Nakina? Did you all agree with me? Yes?
Yes, sir.
Okay, fair enough. So we understand the nth term of an AP series, which is A plus N minus 1 times D. So simple example. Here is a question that we have. If I say, find the 20th term of the sequence and the sequence goes like this: 1, 3, 5, 7, 9, and so on. Right? So this is how the sequence is going. I want to find out what is the 20th term. Is that okay, Nakina? Yes?
Yes, sir.
How do you find this out? Very simple. So first of all, let's talk about the solution of this problem. Okay? Now, if you look at this one, what kind of series is this?
AP.
AP
It's
series.
an AP series. এটা তো কারো কোনো ইয়া নাই, disagreement নাই, আছে?
No, sir.
No, sir.
Okay? So if it's an AP series, remember an AP has two very important parameters, the first term A and the common difference D. So what's the first term A over here?
1.
1. And what's the common difference D over here?
2.
2, which is 3 minus 1, which is 2. Or you can say 5 minus 3, 7 minus 5, whatever. 2 is the common difference, right? Again, now we want to find out the 20th term. Now we know what is the formula for the nth term. What's the formula for the nth term? We figure out
A plus N minus
A plus N minus 1D.
times D. ঠিক আছে? আচ্ছা. Now I want to find out what's the 20th term. So if I want to find out what's the 20th term, তার মানে n এর জায়গায় 20 প্লাগ করব। So A is how much? 1 plus n হচ্ছে 20, so 20 minus 1 times common difference is 2. So that would become now 1 plus 19 times 2. ঠিক আছে? 19 times 2 is 38, right? Yeah. So plus 1, so that would be 39. So this is how you have figured it out. Is it clear, Nakina? ঠিক আছে?
Yes, sir.
Yes,
আর
sir.
স্যার আমাকে যদি বিশ্বাস না হয় তাহলে you can keep on, you know, completing the sequence until you go to the 20th term and check how much is that, and you'll see that that's equal to 39. Is it okay, Nakina? Yes?
Yes, sir.
Yes, sir.
So I hope it makes sense to all of us, right, Nakina? Yes?
Yes, sir.
Yes, sir.
Now, another very important concept that we have whenever we discuss about an AP series, I'm sure you have learned this one in school, is you have to find out the sum of the first n terms. So let's say I want to find out what is the sum of the first n terms of an AP series. How do you find this out? Okay. So let's see what do I mean by this one. So here we are. So we want to find out sum of the first n terms of an AP series. Okay. Acha. Let's see what do I mean by that. Okay. Now, that means we have an AP series. So AP series a format ta kirokom? How does it look like? First term ta koto? A, right? Second term ta koto? Bolen to?
A plus D.
Right, very good. A plus D. Third term ta koto?
A plus
A plus 2D. Fourth term ta koto?
A plus 3D.
A plus 3D, and so on, right, Nakina? This is how an AP series looks like, right, Nakina? Yes? Okay. What we are interested to find is we are interested to find how much is the sum of the first n terms. তার মানে এখানে যে first term, second term, third term, fourth term. এবং এখানে n এর টার্মটা হচ্ছে a plus কত? n minus 1 times t, right, Nakina? এই যে n terms আছে, এই terms গুলোকে যদি আমি add করি, sum করি, that means this one plus this one plus this one plus this one plus all the way up to this one. J sum touch by what is that sum? ঠিক আছে? Right? Nakina? Yeah? So that would be called the sum of n terms of an AP series. Is that okay, Nakina?
Yes, sir.
Yes, sir.
Now I'll represent the sum of n terms as Sn, S subscript n. That means this is the sum of n terms. So as you understand, sum of n terms is the first term is A plus second term. Second term is how much? A plus D.
A plus D.
Plus the third term. How much is the third term? A plus
2D.
2D. And we keep on adding all these terms up to the nth term. ঠিক আছে নাকি না? Okay? আচ্ছা। তাহলে nth term, n minus 1 এর টার্মটা কত পাই? n এর টার্ম যদি a plus n minus 1d হয়, n minus 1 এর টার্মটা কত পাই? a plus n minus 2 times d. Right, Nakina? Yes. Plus the nth term would be a plus n minus 1 times t. Am I correct, Nakina? Agreeable?
Yes, right.
Yes, sir.
So if we sum up all these terms, we get the sum of n terms of this AP series. ঠিক আছে নাকি না? ঠিক নাই?
ঠিক আছে, sir.
Acha. But now the problem is we have a you just keep on adding all of them. Now that's a very tedious process. What we want to look into, what we are looking for is we are looking for a simple formula, right? We're looking for a simple, cute looking formula so that we can just plug all the parameters in that formula and we get the result. Then we do not want to just keep on adding all the terms and then find out the sum of n terms, right, Nakina? Yeah. So we want a very simple version of the formula. That's all the mathematics about, right, Nakina? আচ্ছা, আমাকে একটা জিনিস বলেন দেখি কে বলতে পারে এটা, ঠিক আছে? Of course, যে কেউ বলতে পারবেন, ঠিক আছে? Let's say we are adding 3, 5 and 7. So 3, 5 and 7 add করে যা পাবো আর 7, 5, 3 add করলে কি সেম জিনিস পাবো?
Yes, sir, Papa.
Right. তার মানে হচ্ছে আমি এদিক সাম যদি লেফট টু রাইট করি নাকি রাইট টু লেফটে যাই, doesn't matter, we get the same sum, isn't it, নাকি না?
Yes, sir.
Okay, so I could definitely, therefore, let's just get rid of that. Okay, but of course we'll get the same sum, right, Nakina? Yes.
That's
Nakina?
correct.
Yes, sir.
Yes, sir.
Agreeable, right? Okay. Okay. If it's agreeable, then could I not say sum of n terms as এটা the first term থেকে last term গেছে? Now let's go back from the last term to the first term. আমি যদি add করি, won't we get the same sum? Yeah.
Yes, sir.
Yes,
Yeah,
sir.
by the same logic. So what's my nth term? My nth term is a plus n minus 1 times d, right? নাকি না? That's my nth term plus তার আগের টার্মটা, that means n minus 1th term should be now a plus n minus 2 times d, right? নাকি না?
Yes,
Plus
sir.
তার আগের টার্মটা, that means how much would that be?
A plus n minus
A
3d.
plus n minus 3 times d, okay? Plus you keep on adding all these things, and eventually you come to the second term. Second term is how much? A plus d, and last day you come to the first term, which is a, right, Nakina? Yes.
Yes, sir.
Yes, sir.
Now এটা এখানে আমি যেটা করছি প্রথমটাতে I've added from the first term to the nth term, and second টাতে আমি কি করেছি I added from the nth term to the first term, right, Nakina? But eventually you are adding the same terms, ঠিক আছে? So you get the same summation, so s of n. Agreeable? Yes.
Yes, sir.
Yes, sir.
Good. Okay, খুব ভালো, এটা এগ্রি করতে পারলে। এখন একটা মজার কাহিনী করি, দেখেন। So let's add them up, add these two. So s of n plus s of n, what is that?
Twice, yes, sir.
Twice s of n, right? So that's there. Okay, the next thing that we're going to do, let's add like this way. Look at this way we are adding. So এই টার্মটার সাথে এই টার্মটা অ্যাড করি, 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 right, নাকি না? Yeah, and let's see what happens, what we get. Okay, all right. So a plus a is how much?
2a.
Twice a, plus the remaining things that we have over here is n minus 1 times t, correct, নাকি না?
Yes, sir.
Agreeable to everyone?
Yes, sir.
Yes, sir.
Plus over here, what happens? A plus a, how much is that?
Where?
Twice a plus d plus n minus 2d. What could happen? D plus n minus 2d. Okay, let me help you out. Look at here. As a side note.
N minus 1d.
Okay, good. দেখে d plus n minus 2 times t, right? এখান থেকে কি করতে পারি? আমি d কে কমন নিতে পারি না? d কে কমন নিলে কি হবে? 1 plus n minus 2. Yeah, so that would be equal to 1 minus 2 হচ্ছে minus 1. So this is n minus 1 times d হবে. Correct নাকি না?
Yes, sir.
তার মানে I'm going to get n minus 1 times t. Correct? Is it okay to everyone?
Yes, sir.
Okay, very good. So I'm going to ignore that. Okay, so I'll get rid of that. Okay, plus what about this one? A plus a over here again is 2a plus what is this one? 2d plus n minus 3 times t. What will you get?
N minus 1 times t.
You'll again get n minus 1 times t. Correct, Nakina? Yes. Okay. Plus dot 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 dot, and last of all, a plus a is how much? Twice a plus n minus 2d plus d. N minus 2d plus d is how much? It's the same as this one. N minus 2d plus d, which is n minus 1 times d. Right, Nakina? Yes.
Yes, sir.
ঠিক আছে আমরা নাকি না? And last of all over here, a plus a is twice a plus n minus 1 times t. Agreeable? Naki agreeable now?
Yes, sir.
Yes, sir.
ঠিক আছে? Are we okay? Good? Yes?
Yes, sir.
Yes, sir. Good.
But key. Is this okay to everyone? Naki na? Questions আছে?
Yes, sir.
Okay. আচ্ছা, এখন একটা জিনিস আমাকে খুব মনোযোগ দিয়ে বলেন। খুবই মনোযোগ দিয়ে বলতে হবে তোমাকে, হ্যাঁ? সেটা হচ্ছে এখানে কতগুলো টার্ম আছে এখানে? a থেকে শুরু করে এতটুকু পর্যন্ত। How many terms are there?
N terms.
Right, very good. There are n terms. So if I have n terms here, can anyone tell me how many terms are there here?
And
Also,
Also n terms. Eta hoche is nothing but the reverse of that. তাই না নাকি না? So we still have n terms, right? So a n term is added with a n term. So how many terms would I get over here?
and
N
It's
terms.
also n terms. Very good. So you understand that there are n terms altogether here as well. So there are altogether n terms over here as well. Right? Agreeable, Nakina?
Yes, sir.
Yes, sir.
Yes. So
Yes, sir.
everyone agrees with me on this part. Tana, Nakina? Okay. Now, if everyone agrees with me over here, tell me something over here. Now listen to me very carefully. How much is 4 plus 4 plus 4?
12.
12.
12. 12. But can I also write it as 4 times 3?
Yes, sir. Possible.
আচ্ছা তার মানে কখন আমি এটা লিখতে পারবো? আমি তখনই লিখতে পারবো যখন এই যে যেই টার্মস গুলো আছে, কয়টা টার্মস আছে এখানে? There are 3 terms and each of these terms are equal terms, right? নাকি না?
Yes,
sir.
sir.
If
Yes,
each of the terms are equal terms, then I just take one of the terms and I multiply with the number of terms that we have, which is n equals to 3. Correct নাকি না? Clear?
Yes, sir.
Yes,
Yes,
sir.
sir.
এখন খুব মনোযোগ দিয়ে দেখেন এই যে twice a plus n minus 1d, twice a plus n minus 1d, twice a, তার মানে each of the terms that we have over here are all twice a plus n minus 1 times d. Correct নাকি না?
Yes, sir.
Yes,
Yes,
sir.
sir.
এবং how many such terms are there?
n terms.
N terms. Then what does that mean? That means this twice n can be now written as যেহেতু এটা হচ্ছে equal terms, so I can take one of those terms, which is twice a plus n minus 1 times t, right? নাকি না? Yes?
Yes, sir.
Yes, sir.
Yes, sir.
And then multiply that, like that one. We take one of the terms, which is 4, multiplied by 3, which is the number of terms. So how many terms we have over here?
And
N
So
terms.
just multiply by n. That's it. That's the solution, right, Nakina? Yeah. Now that's 2 times s of n. So what is s of n equal to? S of n would then be equal to n by 2 times twice a plus n minus 1 times d. Agreeable? Yes. So we now have found a simple solution to compute the sum of the first in terms of an AP series. Yes or no?
Yes, sir.
yes, sir.
Yes, sir.
সবাই বুঝতে পেরেছি আমরা নাকি না? বুঝিনি? বুঝেছি।
বুঝছি, sir, clear.
These are the things definitely if guys have done in class 8 or something like that. তাই না নাকি না? Yes? Okay. All right. So for example, if I say find the sum of the first 100 terms, the sum of the first 100 terms of the series of the series 1, 3, 5, 7, 9, and so on. Right? So if I want to solve this one, so first of all, tell me what kind of problem is it? What kind of series is this? Is this an AP series?
AP, sir.
That's an AP series. So what's the first term of this AP series?
1.
1. What's the common difference here?
2.
2. And we are asked to find out the sum of the first 100 terms. এরকম যদি প্রথম 100টা term লিখি and we want to add them up. So the number of terms that we have is 100, right? নাকি না? Yes?
Yes, sir.
And we want to find out what's the sum of the n terms. So sum of 100 terms. So Sn is given by the formula n by 2 times twice a plus n minus 1 times d. Correct, Nakina?
Yes, sir.
Yeah? So your S100 would become, you plug n as 100, so it's 100 by 2 times twice a, which is 2 times 1, plus n minus 1, n is 100, minus 1, times the common difference, so it's 2. Correct, Nakina? Okay, so if we evaluate this one, this would be 100 by 2, okay, times this is 2, plus this is 99 times 2. How much is 99 times 2? 198, correct? Nakina?
198.
Okay, if it's 198, this is 200. So 200 divided by 2 is 100. 100 times 100 is how much?
Yes.
10,000.
That's the answer. So 10,000 is the answer. ঠিক আছে? Now, if you don't trust me, of course, you can write down the first 100 terms and add that up. That's your choice. but I think you get a very straightforward answer, right? Nakina, clear?
Yes, sir.
ঠিক আছে? Are we good, Nakina? So far so good?
Good, sir.
Yes, sir.
So far so good. So I think this is the basics of the epi series that you guys already know it from the school, right, Nakina? Yeah. Okay. Now, sometimes in mathematics, you might see terms that you might see, problems like this one. Like, what is sigma? Sigma means what?
Some.
Summation. Okay. Sigma k, where k, so the expression is k, and the k is going from 1 to, let's say, n. Anyone knows what's the formula for this one?
K1 থেকে Kn পর্যন্ত sample.
হ্যাঁ, ঠিক আছে. Does anyone know a formula for this expression? Okay, did you ever see that this is equal to I think you have forgotten it right now. Have you ever seen things,
Yes.
formulas
Yes,
like
sir,
this?
right.
Yes,
Yes,
sir.
sir.
How do you get these things? Where do you get these things from? ঠিক আছে? Okay. Now, many people just I have seen many people just memorize these formulas, okay, without really looking into why do we get formulas like this. Okay, so let me show you very quickly why do we get things like that. K equals to 1 to n of k. Now, what does it mean? Sigma means summation, so I'm asking you to sum the expression k from k equals to 1 to n. So that means when k is 1, then the expression k is 1 plus the next value of k is 2. So k is then 2 plus the next value of k is 3, then this is 3 plus, and you keep on going until how much? K equals to n porjonto. So you keep on adding plus when k is n, so this k would become n. So this is the summation that you want to find out. Now, if you look at this one right now, what kind of series is this?
AP series.
It's nothing but an AP series, and you're just doing a summation of this AP series from 1 plus 2 plus 3 up to n. So, a summation kochi, summation a formula key. What is the formula? The formula is n by 2 twice a plus n minus 1 times t. So, how many terms are here? 1 থেকে n. So, there are n terms. There are n terms. What's the first term here?
1.
1. And what's the common difference here?
1.
1. So if that's the case, so this would be now n by 2 times twice a. A is the first term is 1 plus n minus 1 times the common difference is also 1. Correct, Nakina? Yes?
Yes, sir.
So that would mean this would now become equal to n by 2 times 2 plus n minus 1. Correct, Nakina?
Yes, sir.
So this would be n. এখন 2 minus 1 কত n, so n plus 1, so n times n plus 1 হয়ে গেল, divide by 2. So did you get the formula?
Yes, sir, got it.
So basically that's how you do it. Okay, right? This is nothing but an AP series. Are we good, Nakina? Yes?
Yes, sir.
Okay, so time will not permit me, but let me just write down some more, another interesting formula, but time will not permit me to show you how this formula comes in right now. Okay, but I'll just write this one. You might also see another formula like this. Sigma k equals to 1 to n of k square. Now this is not going to be an AP series, but in any case, the formula would be something like n times, does anyone remember what's the formula for this expression? মনে আছে কারো? নিশ্চয়ই করেছেন আপনারা আগে. Okay, so I guess you don't remember it. The expression would be n times n plus 1 times twice n plus 1 divided by 6, something like that, right?
Yes, sir.
Yeah?
Yes, sir. ঠিক আছে।
আপনার কিছু মনে নাই, ঠিক আছে? বাট এইসব এক্সপ্রেশনস গুলো কিন্তু আমাদের আস্তে আস্তে কিন্তু যখন আমরা অ্যালগরিদম অ্যানালিসিস করব কোন কোন জায়গায় আসতে শুরু করবে, সো ডোন্ট ফল ফ্রম দ্য স্কাই, ঠিক আছে? ওকে, these are the things that you learned in school. ঠিক আছে? Are we good, Nakina? Are we clear?
Yes, sir. Yes, sir.
Good. So we have seen an AP series. I've got about 10 minutes left, so let me try to do an equal justice in 10 minutes to discuss the GP series as well. Take a chance. So let's see the GP series very quickly. GP series, or it's also referred to as an exponential series. Take a chance. All right. But I'm going to use the word exponential series later on to discuss further about the behavior of exponential series. Okay. but that's also referred to as exponential series. Okay, so GP series or geometric progression, series. How does it look like? Now, examples. Let's see some examples of GP series. Can you tell me some examples of GP series? How does it look like?
1, 3,
Okay, here's an example. 2, 4. তারপর next টার্মটা কি হবে বলেন তো দেখি?
8,
8. Next term?
16,
16.
Here's the GP series. Okay, ঠিক আছে. Here's the GP series. Keeps on going. Okay, here's another example. What if we have 2, 6? What's the next one?
18.
18. Next term? 54. And so on. Right? What about here? 3, 1. What's the next term now?
1/3.
1/3. What's the next term then?
1/9.
1/9. Okay, and so on, right? These are all examples of GP series. So what's the real property here? The real interesting property here is we do not have a common difference now. Like 4 minus 2 is 2, but 8 minus 4 is 4. But what we have is a common ratio. 4 divided by 2 is 2, 8 divided by 4 is 2, 16 divided by 8 is 2. So we have two things here. The first term, so again, like an AP series, the GP series also have two very important parameters, the first term and the common ratio. So the first term here is 2 and the common ratio is also 2. Is that okay, Nakina? Clear?
Yes, sir.
For the second GP series here, the first term is 2. What's the common ratio? 3. 6 by 2 is 3, 18 by 6 is 3, and so on. For this one, the first term is how much? 3.
3.
And how much is the common ratio?
1/3.
1/3. You get 1 divided by 3. Okay. Now, if this is these are some of the examples of a GP series. Now let's look at a pattern, general pattern of a GP series. So if you look at the general pattern of a GP series, you'll see some interesting thing here. Okay. So first term is A. What's the next term? Now look at here. This was 2. Next one is 4. So what you did is you multiplied 2 by 2. What is that 2? Common ratio 4. The next term, you take the previous term 4, multiply by the common ratio 2 to get the next term. 8 to 16. You take the first term, previous term 8, multiply by the common ratio 2. So if you have the first term is A, what's the next term?
AR.
AR. You multiply by the common ratio. What's the next term?
AR square.
AR times R, which is AR squared. The next term is AR squared times R, AR cubed, and so on. Clear, Nakana? Is that okay?
Yes.
Yes,
Yes,
sir.
sir.
So that's really the general pattern of a GP series. Now, if you actually also look at the term number, like the way we have done for the AP series, if you look at the term number, now this A is the first term, second term is AR, third term is AR squared, fourth term is AR cubed. So can you see over here that there is a specific pattern for the nth term? What is that? Fourth term is AR cubed. Cubed means 4 minus 1. AR squared, 2 power 2 is 3 minus 1. So nth term would be how much? AR
minus 1.
minus 1. Right. So the nth term of a GP series, therefore, comes out to be A times R to the power n minus 1. Is it understandable to everyone?
Yes, sir.
Okay. So I want you to remember this one. Okay. Are we happy? So do we understand this? That this is the nth term of a GP series? Yeah?
Yes, sir.
Okay. Now that we know the nth term of a GP series, now the question is, what's the sum of the first n terms of a GP series? Sum of the first n terms of a GP series. So let's try to look at that. Sum of the first n terms of a GP series, right? Okay. Now, of course, sum of the first n terms, which is S of n, is we're going to take each of the terms, the first term, the second term, the third term, up to the nth term, we add them up. So what's the first term of a GP series? A, right? Yes?
Yes, sir.
Yes, sir.
Plus, what's the second term?
AR.
AR. What's the third term? AR squared plus the fourth term, plus
AR cube.
and so on, keep on doing that, because we want to find out the nth term. So the nth term of a GP series is AR to the power n minus 1. And when you add all these things, that's the sum of the first n terms of a GP series. Is that okay, Nakina?
Yes, sir. Okay.
Yes, sir.
Sir.
Okay, now let's do some interesting thing here. Let's take the sum of the first n terms and multiply by r. Simply, we are multiplying by r. So if you multiply by r, this would be AR plus this is AR times r, which is AR square, plus this is AR square times r, which is AR cubed, right? Plus you keep on doing that up to here, AR to the power n minus 1 times r. How much is that?
AR to the power n.
AR to the power n. Is it agreeable, Nakida, to everyone? Can I
Yes,
do
sir.
something like that? I can. Right. Good. Now, what I'm going to do now is look at this one here carefully. I'm going to subtract the, RSN from Sn. If we do that, I'll get over here S of n minus R times S of n. Right, Nakina? Yes?
Yes, sir.
And this subtraction is very interesting because if you see, I'm subtracting the second expression from the first expression that we have. And when we do that, this AR and this AR minus AR, they will cancel off, right, Nakina?
Yes, sir.
And this AR square will cancel off this AR square, right, Nakina? Yeah?
Yes,
Yes,
sir.
sir.
Yes, sir.
And similarly, all these things will get cancelled off. Everything will start getting cancelled off. Even this one will get cancelled off. What we are left with is, from the first one is A, and from the second expression, AR to the power n. And because we are subtracting, this will be left with A minus AR to the power n. Yes?
Yes, sir.
Okay.
Yes.
If that's the case, then I can take Sn as the common. Then we will have 1 minus R. Over here, I can take A as common, which would be 1 minus R to the power n. So your sum of n terms of this GP series would be A times 1 minus R to the power n divided by 1 minus R. Agreeable?
Yes, sir.
Yes, sir.
Okay.
Yes.
ঠিক আছে। এটাকে আমি এভাবেও লিখতে পারি, this is the same as A times R to the power n minus 1 divided by R minus 1. এভাবে লিখতে পারি না? একই কথা?
Yes, sir. Change correct.
Okay, হ্যাঁ। But another important thing is your common ratio R cannot be 1. ঠিক আছে? কারণ common ratio যদি 1 হয়ে যায়, then
Yes.
denominator 0 হয়ে যাবে, and then the expression will become undefined. Is that okay, নাকি না? Yes?
Yes, sir. Yes, sir.
Okay. Now, both this formula for sum of n terms is fine, but আমরা usually দেখা যায় ম্যাথমেটিক্স এর আপনারা যদি আপনাদের বইগুলোতে হয়তো বা দেখবেন যে এই এক্সপ্রেশনটা ইউজুয়ালি ইউজ করেছে তারা যখন কমন রেশিও স্মলার দ্যান 1, আর এই এক্সপ্রেশনটা ইউজ করেছে typically when the common ratio is larger than 1, right, নাকি না? Yes, but it does not matter. Common ratio যদি larger than 1 হয়, আপনি এই এক্সপ্রেশন ইউজ করতে পারবেন। common ratio যদি smaller than 1 হয়, আপনি এই এক্সপ্রেশন ইউজ করতে পারবেন, you'll get the same result. The only reason why they do it in typical textbooks is for convenience, because common ratio যদি larger than 1 হয়, তাহলে r minus 1 this is positive, কোনো নেগেটিভ নাম্বার নেই, কিন্তু এই এক্সপ্রেশন ইউজ করলে ডিনোমিনেটর নেগেটিভ আসবে বা নিউমারেটর নেগেটিভ আসবে, নেগেটিভ ক্যান্সেল হয়ে যাবে। So if you don't want to complicate the things, okay, that's what you do. That's just a matter of convenience, nothing else. Is that okay, Nakina? Yes?
Yes, sir.
Yes, sir. Okay.
ঠিক আছে, are we all good? Okay.
Yes, sir.
Right. Okay. So this is your GP series. So you know how do you find out the sum of n terms of the GP series as well. Okay. Acha. Now there is one thing that I wanted to cover. Let me actually take 2 or 3 minutes more. Okay. I know we are already 4:10, hitting 4:10, but let's take 2 or 3 minutes more because I want to discuss something which is very important related to GP series, and you will find this one very useful. Okay. So let's discuss this one very quickly. Okay. Acha. Now, you know, in a GP series, common ratio cannot be 1. Common ratio can be larger than 1, can be smaller than 1, but cannot be 1, right, Nakina? Yes?
Yes, sir.
Now, if common ratio is larger than 1, it behaves in a very interesting way. And if common ratio is smaller than 1, okay, but positive, it behaves in a little bit different way. So let me show you how they differ. Okay? So common ratio is larger than 1. Let's take an example. Common ratio larger than 1. Give me a value of common ratio larger than 1. 2.
Sir, 2.
right? 2 is larger than 1, right? You can take any number which is larger than 1. Let's say 2. Is that okay, Nakina? Yeah? Okay.
Yes, sir.
And let's say the first term is, keep it simple, 1. Now let's take this as an example. Now if we do that, তাহলে আমার geometric series টা কেমনে progress করবে? First term is 1. What's the next term? AR, 1 times 2. 2. তারপরটা
sir.
কত? তারপরটা কত? 4. তারপরটা কত? 8, 16, 32, 64, right? Nakina, yes? And
Yes,
so
sir.
on.
Yes, sir.
Yeah, good. Now, that would mean if I plot a graph like this way, okay? Look at this carefully. Y-axis is the nth term plot kori, or x-axis is the number of terms n plot kori, then the first term is 1. So first term, second term, third term, fourth term, fifth term. Let's see this one, okay? First term is 1, so 1 is here. So let's 1 is here. Second term is 2, double. It's a double, so somewhere here. Third term, it's a double, double, right? It's a double, which is somewhere here. Fourth term, it's a arrow double, right? Somewhere here. So I'm usually plot query graph. Won't the graph look like this?
Sir, exponential one.
So it's rising like this way, isn't it, Nakina? Yes?
Yes, sir.
তার মানে কি বলতে পারি, যত n এর ভ্যালু বাড়ছে, as n is increasing and increasing, that means as n approaches infinity, তাহলে আমার এই টার্মের ভ্যালুটা কি বাড়ছে না কি কমছে? n এর টার্ম কি বাড়ছে?
Increasing, sir.
Right? যদি n এর টার্ম বাড়ে, sum of n terms কি হবে? এটাও বাড়তে থাকবে, right? Because sum of n terms means you are adding all these things, all values, this plus this plus this. The fourth term you add this one as well. তাই না নাকি না? Yes?
Yes,
Correct,
sir.
sir.
So n যত বাড়তে থাকবে, sum of n terms কি হবে? তত বাড়তে থাকবে. So if n approaches infinity, sum of n terms also approaches infinity. Right, নাকি না? Can I say that?
Yes, sir.
Yes, sir.
Okay. Now that's what's going to happen if the common ratio is larger than 1. Okay? Agreeable, নাকি না?
Yes, sir.
Okay. However, if that's not the case, if let's say the common ratio is not larger than 1, let's say that the common ratio is smaller than 1 but larger than 0, that means it's still positive but it's smaller than 1. তখন দেখবেন যে এইটার property will change a little bit. ঠিক আছে? And we'll see how does it change. So let's take an example. Okay? Common ratio is smaller than 1. An example done.
1/3, sir.
1/3. Good. So you can say it's a 1/3. Okay, just for simplicity, let me say a half. Is that okay, Nakina? Yeah?
Yes, sir. Okay.
Yes, sir.
Okay, এখন একটা first term নেই, let's say first term is 16. 1/3 নিলেও হবে, but just for the sake of quick calculation, I took it as half, right? First term 16. So তাহলে how does the GP grow? First term হচ্ছে 16. What's the second term?
8.
8.
8,
16
sir.
times half, which is 8. 8 times half,
Four.
what is that? 4. 4 times
Four,
half,
one.
which is 2. 2 times half is 1. 1 times half is half. Half times half is 1/4.
Okay.
1/4 times half is 1/8, and so on, right? Thank you. Now this is how it's going to grow. Yes or
Yes,
no?
sir.
Yes, sir.
আচ্ছা, সেম জিনিসটা যদি এখন আমি প্লট করি, এখন দেখেন, I'm going to take 2 more minutes and then we're done. ঠিক আছে? Okay, that's the same জিনিসটা আমি প্লট করছি. So here we are. This is the nth term. This is the value of n, right? নাকি না? Okay, so n equals to 1 এ কত হবে, 2 তে কত হবে, sorry, 3 তে কত হবে, 4 এ কত হবে, 5 এ কত হবে. Let's say we want to plot it. 6 enough. So first term is 16, so let's say 16 is here. Okay, second term হচ্ছে 8, so 16 আর half, তার মানে এই হাইটটা হচ্ছে half হবে, 8, so roughly here, right? নাকি না? থার্ড টার্মে হচ্ছে আরো হাফ, তার মানে এই হাইটের আরো অর্ধেক, so somewhere here. ফোর্থ টার্মে এই হাইটের হাফ হয়ে যাচ্ছে, রাইট? ফিফথ টার্মে আরো হাফ হচ্ছে, সিক্সথ টার্মে আরো হাফ হচ্ছে। তাহলে how does this graph look like? Doesn't the graph look like this? Something like
approaching
this?
zero, sir.
এইভাবে যাচ্ছে।
Sir,
তার
times
মানে
2 হবে।
well sir, মানে if n approaches infinity then this would be almost zero, right? নাকি না? Yeah?
Yes, sir.
Right. তার মানে এই এখন আপনার কি হচ্ছে, the property has changed, isn't it? Now this time as n approaches infinity কি হবে? What would be Sn?
Tends to 0 হবে।
Zero.
No. S of n means sum of n terms. So sum of the first term is this part, 16. Sum of the first two terms would be 16 plus 8, 24. Sum of the first three terms would be 16 plus 8 plus 4, which is 26, right? So sum of n terms বাড়তে থাকবে, কিন্তু বাড়তে থাকবে at a reducing rate. Eventually, as n tends to infinity, তখন দেখা যাবে when it's almost zero, তখন sum of n terms কি আর বাড়বে?
না
আর
স্যার।
বাড়বে না, it becomes constant. So sum of 10 n terms then would approach a constant value, or they approach a constant value. Is it clear nakina? Yes.
Yes, sir.
Yes, sir.
Okay, so unlike the previous example where the sum of n terms approaches infinity, this time the sum of n terms would approach a particular value, a constant value. Is it clear nakina? Yeah. So that means if the common ratio is smaller than 1 but positive, then the sum of n terms as n approaches infinity would approach a constant value. Is it okay nakina? Yes.
Yes, sir. Okay.
Okay. And how much is that constant value? I'll show you this one in 1 minute time. As n approaches infinity, what do you think would be r to the power n approach? R is a common ratio which is smaller than 1. Let's say common ratio ধরে half হচ্ছে। Half whole square কত হবে? বলেন তো? Half whole square কত?
1/4.
1/4.
1 quarter. A half whole cube কত?
1/8.
1/8.
1/8. আর n যদি ইনফিনিটি হয়ে যায়, half whole to the power n কত হবে? ইনফিনিটি কত হবে?
Tends to
difference.
এটা আরো কমতে থাকবে না? Yes. কমতে কত? 0 হয়ে যাবে না?
জিরোর কাছাকাছি স্যার।
zero.
Approaches zero. Can I say that নাকি না?
Yes, sir.
Yes, sir.
So remember the sum of n terms of formulaটা কি ছিল? A times 1 minus r to the power n divided by 1 minus r. This one was for the GP series, right নাকি না? Yes.
Yes, sir.
So now I can say as n approaches infinity, n যখন infinity approach করে, then what would be the formula for sum of infinity? A times 1 minus what is r to the power n going to be equal to?
0.
0 divided by 1 minus r. So the formula will become a divided by 1 minus r. So that's what we are saying, that in this case, okay, when common ratio is smaller than 1, when n approaches infinity, sum of n terms will approach a constant value, which is a divided by 1 minus r. Is it clear, Nakina? Yes?
Yes, sir. Yes, sir.
We'll stop here. I have already taken 10 minutes more. I think we should stop. Okay, is it clear? But I
Okay,
hope
sir.
it makes sense, right, Nakina? Yeah? Okay?
Yes, sir.
All these concepts you actually have learned in school, but this will come back. So I thought of like discussing it in the first class. Okay. All right. Okay, good. So I'm going to stop the recording. Okay.
Sir,